So in this lecture, we're going to be talking about chemical bonds. We're going to be talking about why those chemical bonds might form, and we're going to be talking about the different types of chemical bonds that two or more elements can form with one another. So let's do a quick review from the last lecture. You should know how to draw electron diagrams. Specifically, you should know how to draw valence electron diagrams. And you should be able to use the periodic table to determine the number of valence electrons that an element has. It's super easy. We're going to review it again today. And you should also remember the octet rule. And what the octet rule means is just that any particular element wants to have a filled outer shell of electrons. It wants that outer valence shell of electrons to be full. And that's because when it has a full shell, that's its most stable configuration. So elements are the most stable when they have all of their outer electrons filled up. And so they want to fulfill that octet rule. So let's think about salt really quick. So here we have an Na and a Cl. And if you remember from yesterday, the reason that Na and Cl got together is because Na has one valence electron. Actually, everything in this group has one electron in its outermost shell. And so you can actually group these things. So everything in this group has similar properties. These are called the alkaline metals. Everything in this group, everything in this column has similar properties. These are called alkaline earth metals, okay? So how many valence electrons do these alkaline metals have? One. How many valence electrons do alkaline earth metals have? Two, right? So these have one, these have two. Then we're going to skip the transitional metals and the lanthanides and actinides, which we'll talk about later. Everything in the boron group has 3 valence electrons. Then everything in the carbon group has 4 valence electrons. Everything in the nitrogen group has 5 valence electrons. Everything in the oxygen group has 6 valence electrons. Everything in these are called the halogens. So everything in the halogen group has 7 valence electrons. And everything in this is called the noble gas group, has 8 valence electrons. So everything in the noble gas group already has a filled valence shell. It's already full, and so these noble gases are not going to want to react. And everything in this noble gas group here has similar properties. They're all non-reactive. Everything in the halogen group is very close to having a filled outer shell, so everything in this group is very reactive. Okay, so anyway, back to what we were talking about. Why do Na and Cl get together? So sodium, Na, is right here. It's number 11. It's an alkaline metal. It's in the first group. So how many valence electrons does it have? It has 1 valence electron. So what does it want to do? It wants to have a filled outer shell, so it's going to want to get rid of that electron, right? Because as soon as sodium gets rid of that electron, it's going to have a filled outer shell. What does chlorine have, or how many valence electrons does chlorine have? Well, let's count them up again. 1, 2, 3, 4, 5, 6, 7. Chlorine has 7 valence electrons. So it wants to gain 1 more, so it can look more like its buddy here, argon. It wants to have a filled outermost shell. So it's going to grab sodium's electron. It's just going to steal the electron away from sodium. Hopefully you remember that electrons have a negative charge. Okay, electrons have a negative charge. And so when chlorine steals that negative charge away, chlorine is going to become more negative. What's going to happen to sodium? Well, sodium's going to become more positive. And so in chemistry, opposites attract. And so chlorine and sodium are going to now be hanging out with one another because chlorine is negative, sodium is positive, so they are together. Okay, this is called an ionic bond. Okay, ionic bonds happen between metals and nonmetals, to which your next question should be, wait, sure, but how do we know what's a metal and how do we know what's a nonmetal? So I borrowed this off of the internet. Our metals are pretty much everything on the left here. Everything on the left is a metal, with the exception of hydrogen. Hydrogen does not count. Hydrogen is a nonmetal. Okay, so everything on the left, the whole left-hand side of the periodic table is a metal. And everything on the right in this top corner is a nonmetal. Okay, I'm going to give you this information. So I'm not going to ask you, and I'm not going to ask you about any, like, I'm going to be like, hey, is arsenic a metal or a nonmetal? This is not chemistry. But I will ask you to know that ionic bonds take place between a metal and between a nonmetal. Okay? So anytime you have a metal and a nonmetal, it's an ionic bond. So let's predict some other kinds of ionic bonds. I've been kind of giving you guys a simplified periodic table, so I just figured I'd give you a more full-looking one. Sometimes you get lots of this extra information on the top. People can add even more in. Like there's a group added here. I've added the lanthanides and the actinides. Don't worry about them. Just kind of go with what you know. But let's get my. So let's pick some nonmetals, and we'll put our nonmetals here. If I can get this thing to work, we'll put our nonmetals in like dark blue. But let's just take like, I don't know, we'll take potassium. So how many valence electrons does potassium have? Well, you should notice that it is in the first group. So it has, wow, that's a really bad electron. It has one, potassium has one valence electron. All right, so it wants to either gain 7, but it's going to probably just get rid of this one because that's a lot easier than picking up 7 more. So what is potassium going to be most likely to get together with? Well, it's most likely to get together with one of these group 7 elements. Okay, so you could have potassium, we'll put the non-metal in, we'll do dark green. You have potassium iodide, okay? Because remember, iodine has 7 valence electrons. So let's stick those on here. 1, 2, 3, 4, these are so bad. 5, 6, 7. Oh boy, pretty horrendous. So what's going to happen though is iodine is going to want to take this electron from potassium. Potassium's certainly going to want to get rid of it. But then when iodine takes this electron away, it gains a negative charge, right? And potassium, since it lost its electron, gains a positive charge. And so what winds up happening is you have a neutral molecule, potassium iodide, Ki. Okay, this is a salt. So like the high school definition of a salt is the product of an acid and base being neutralized. But the chemistry definition is anything with an ionic bond. That's not important. I'm not going to ask you that, but if you guys were curious, maybe you took high school chemistry or something. But here is potassium iodine. It is an ionic bond, okay, and this is a salt. Let's predict some more. So let's see. Let's go to our alkaline earth metals here. Let's pick on calcium. I like calcium. Maybe these blues. We have calcium. How many valence electrons does calcium have? Well, it's in the second group here. Remember, 1, 2, skip a bunch, 3, 4, 5, 6, 7, 8. So calcium has got 2 valence electrons. What is it most likely to hang out with? So remember, it wants to get rid of those. It wants to get rid of those 2 electrons. Let's see if we can do. Oh, here we go. So we've got calcium with our 2 electrons here. It's probably going to hang out with one of these group sixers, right? Because these have 6 valence electrons, so they want to gain 2 more. We were making those green. So let's just grab, we'll just grab oxygen. And how many valence electrons do we have in oxygen? Well, we have 6, right? 1, 2, 3, 4, 5, 6. Those are dumb looking electrons. I apologize. So then, though, what's going to happen is oxygen is going to steal both of these electrons. What's going to happen to oxygen when it steals 2 electrons? What happens to its charge? It gets a 2 minus, right? And calcium over here gets a 2 plus. And so those 2 are then going to hang out together and form calcium oxide with a neutral charge. So oxygen steals electrons, becomes more negative. Calcium loses its electrons, becomes more positive, and it forms this ionic compound over here. So yeah, if you guys want a little bit of extra credit, and again, it needs to be specifically formatted, I think I'll have it be called, put the subject line as ionic bond extra credit, and just predict a few more of these ionic compounds for me. Just type into the, you don't need to say, hey, Aaron, or anything like that. Just put ionic compound extra credit, or ionic bond extra credit. I've said both, so either of those will work. And then put in the body just put 2 different ionic bonds that you think will form. If you get them right, I'll give you some extra credit. Oh yeah, and they need to be unique ones too. They need to be ones that we didn't just do on the lecture just now. So 2 unique ionic bonds.